Welcome to qnawire.
Hi, so for this question, we are dealing mainly with the Henderson-Hasselbalch equation, which tells us that pH is going to be equal to pKa plus the logarithm of the concentration of the conjugate base divided by the concentration of the associated acid. So now, before we begin, I want you to realize that if we have A minus and HA, and we have the same total volume, this is the same as taking the ratio of the amount of mole that we have of each, because the total volumes are going to cancel out. Recall that that is directly the definition for molarity that we have. Okay, so we can replace this ratio directly by the ratio of the amount of mole that we have. In our case, we have formic acid, which has a Ka of 1.8 times 10 to the minus 4. Recall that pKa will be equal to minus the logarithm of Ka, which in this case will be 3.74. Actually, if you want 3.745, just to be extra precise about it. So we can calculate directly the pH. We are told that we have zero point 0.2 mole of formic acid, which is HCOOH, and we have 0.15 mole of sodium formate. Out of the sodium formate, the only thing that I care about is the formate ion. Remember that this is going to be the anion that goes into solution when we put the sodium formate into water. So our pH will become 3.745 plus the logarithm, the amount of mole of the conjugate base, divided by the amount of mole of the acid, giving us a value of 3.62 for pH. Now let's see what happens when we add 0.01 mole of OH minus of sodium hydroxide. What we can see is that OH minus is going to react with the acid, right? So we have HCOOH plus OH minus will react to produce HCOO minus. We can do our ice table in terms of moles directly. We begin with zero point 0.2, we add 0.01, and we have here 0.15. The amount of change is given by the limiting reagent, that is going to be the OH minus. So at equilibrium we have 0.19, 0, 0.16. And we are going to use these quantities into our Henderson-Hasselbalch equation again. So pH is now going to be the same pKa plus logarithm, the amount of mole of the base, 0.16, amount of mole of the acid, 0.19. The pH is going to be equal to 3.67. Nice. Now let's look at the other possible case. We're going to add 0.01 mole of HCl. That is the same as adding H3O plus to the solution because, sorry, of nitric acid, HNO3. But since that is a strong acid, the amount of mole that we add of the strong acid is going to dissociate completely and generate hydrogen ion. So now the reaction that we are going to be looking at is the formate ion plus H3O plus is going to react in order to generate formic acid plus water. We can go ahead with our ice table. Again, this is going to be in terms of mole. We begin with zero point 0.2. We add 0.01. Sorry, over here we begin with 0.15. Sorry about that. And we have zero point 0.2 initially. The amount of change, again, it is going to be given by the limiting reagent, that is the hydrogen ion. At equilibrium, I'm going to get 0.14, something close to 0, and 0.21. Okay, so we can use these quantities, the ones at equilibrium, again for our Henderson-Hasselbalch equation. So pH is 3.745 plus the logarithm, the concentration of A minus, now it is 0.14, of HCOH is 0.21, and this is going to give us a pH equal to 3.57. And that would be all. These are the pH that we have after the additions and the original pH that we had at the very beginning. So, with that out of the way, thank you very much. Have a good one.